JavaScript. Okay, the recording has begun. So let's start. Our today's lecture will actually be a continuation of our previous lecture. Last time we studied inheritance, and the lecture before that we were studying BOM, the browser object model, and we have introduced ourselves to event loop, to asynchronous JavaScript, to how set timeout work, how promises work, how set interval works, and so on. So today's lecture will be a build-up of that, and to make it easier on us, let's first do a short recap of what we have learned before. So today we will be talking about Ajax, asynchronous JavaScript, and its purpose is to send network requests to the server and load new information whenever it's needed. Like it's one of the main purposes how we're using our applications right now. We are sending requests to the server using JavaScript, then we are receiving the response, and we are updating the visual part, the user interface of our applications with JavaScript without fully reloading the page. We have learned what single page application are previously, and we are displaying swiftly this new information to the user. So let's refresh our memory on what a URL is, because when we are going to the server, we will be hitting a URL. We will be sending a request there. So first, at the beginning of the URL, there is the protocol we are using. It can be HTTP or HTTPS. HTTPS S here means that the protocol is secure. And we have studied that this is usually reserved for when you are sharing your username, your password, or maybe your credit card data, making some payments online. When you are using HTTPS protocol, and you can also see like a small lock in your browser when this protocol is being used. It means that the data cannot be get in the middle, like some people who would want to get your data because it's transferred securely, it's transferred encoded, they cannot get to it. So HTTP protocol, this data is not secure, and somewhere in the middle between you and between the server, someone can intercept it and view it. That's why we're using HTTPS for all sensitive data. Then after the protocol, we have the host name, the port. When you will be developing applications, you will usually see that the front-end part of your application, when you're running it locally, is being run on one port. Usually it's 3030. And the server part of your application will be run on another port, usually 8080, but this is custom and you can configure it as you please. And then the path. The path, as we have studied previously, is a very easy and useful way for us to store information on the client. Like when we are making some changes in our web applications, for example, here on Amazon.com, we are searching for Edge of Tomorrow, and we have a reference, and we are at the search part of the page. Like search, for example, is a name of the section of the page, and this part is called hash. And if we share this page via social media or just by sending links to our friend, the website will analyze this query, this search part, and see that, I shall not redirect them to just the homepage of Amazon.com. I shall also run the search for Edge of Tomorrow, and I shall navigate them not to the beginning of the page, but to the search section. So this is very useful when transferring data. But the main piece of what we have studied previously is the event loop. This is quite a difficult topic, so let's quickly brush up our memory on that. JavaScript as a programming language, it's synchronous. So it can only do one operation at a time. And we have studied that this is being done with what is called a call stack. And as on call stack, as we can see, function 1 is below function 2 and function 3 is above them all. Call stack is executing task based on the principle last in, first out. So the task which was added to the call stack, the last, will be executed first. So for example, if we have three functions nested inside each other, function 1 is the parent, inside of it we have function 2, and inside of this function we have function 3. When we are executing our code in JavaScript, the interpreter, JavaScript is an interpreted language, it's not being compiled, it's being run line by line without previous compilation. The interpreter will see this function 1. It will not interpret it yet. It will read that inside there is function 2. It will put it on the call stack above it. It will see function 3 inside function 2, put it on the call stack as well. And finally, by saying that there is nothing else inside function 3, it's the last one. It will first execute function 3, remove it from the call stack, then function 2, execute, remove from call stack, then function 1, execute it, remove it from the call stack, and by now the call stack is empty and we can do some other actions. And by studying event loop, we learned how JavaScript, by leveraging the web browser API, we are able to run asynchronous tasks. Like all operations with the browser, with the document object model, they are asynchronous. Set timeouts are asynchronous. Promises are asynchronous. And what we will be studying today, the Ajax asynchronous JavaScript. As it's being told in the name, it's also asynchronous tasks. All requests that you are sending to the server, they are synchronous by nature because you are not receiving the result momentarily. You are sending the request. There is some delay. It's usually called ping. For example, it's called ping in most of video games. And then after some time, you will receive a response from the server and pass it. So as not to block our application while it's waiting for information to return from the server, we are running this code asynchronously. And we have learned that event loop is like making an orchestra work. So we have the call stack, we have the microtasks queue, tasks queue, and render queue. And event loop is managing all these queues and putting the code from them to the call stack to be executed when it is empty. So for example, we have our synchronous code, these three functions, and after all of them starting from function 3 have been executed and call stack is emptied, our event loop can look at the microtasks queue, and we know that all promises and mutation observers are on the microtasks queue, and execute them. And we learned that there is an important difference between microtasks and tasks. Promises and other microtasks, they are being executed one by one until the microtasks queue is totally empty. Only then event loop is passing it back to the call stack, allowing the synchronous code to be run again. That's why you shall be careful in that with promises, you can actually create a loop, for example, while true loop, which will be infinite. And with this loop, you can totally block your application, like it will be unresponsive, clicking your mouse, inputting something from the keyboard, trying to interact with your application in any way, it will not work. Why? Because microtasks are being run continuously, and due to the loop being infinite, new microtasks are being added. But this is not a problem for the tasks. And we learned on the previous lectures that set timeout, set interval, and Ajax, all the requests to the server that we will be studying in more detail today, they are the tasks. And these tasks are being executed one by one. So we have executed our code, synchronous code, on the call stack. It has been emptied. Then event loop is looking. Microtasks, are there any? They have higher priority. No microtasks. Okay, then tasks. Are there any? Yes. There is, for example, this set timeout. Then I'm running it, but instead of immediately running the next task from the task queue, we are again allowing the synchronous code go onto the call stack, be executed, and then once call stack is empty once more, we look at the microtasks and tasks queue again and execute only one task. So the most important difference is that microtasks queue is being emptied all at once. Every task in the microtask queue is being executed when event loop is executing these tasks. And in tasks queue, only one task will be executed, and then it's back to call stack. And only when it's empty again, we will execute another task. And the very special third queue, the render queue, this is a bit of a more advanced topic. And usually in your work, you will not be working with render queue very closely, at least in the beginning of your developer path. So the most important things to remember are microtasks and tasks. And about render, just know that it exists and your monitor is updating with what is called a frame rate. So it's not being updating after each and every small change that you make on your screen. For example, even when you are moving your mouse, you can be moving it extremely quickly. Like you can drag and drag it on your touchpad and you will move your cursor very, very, very quickly. But it will not be updating so quickly. You have the frame rate. It's how frequently your monitor will actually repaint the pixels on it. So the render queue, it is stacking all the changes in between these frame rates. So frame 1, your screen is in such a state. Then some things start happening. You are moving your mouse, maybe some notification has appeared, something else. And after the second frame it is time to display the second frame. Usually it's very quickly. Your monitors are usually updated with like 60 gigahertz. It's like 60 times per second, but no more quickly. So even if you did 300 actions during the second, your monitor will only update 60 times per second. So render queue, it is responsible for aggregating all the changes that happened between one pixels repaint and another pixels repaint based on the frame rate on your monitor, on your screen. And then it is updating all these pixels all at once based on all the aggregated actions. And this render queue, it's also asynchronous and it is being updated based on when other actions are not being displayed. So just remember that render queue exists, but it's not very important right now to try to get in the nitty-gritty bits of this thing. Today, we will mostly focus on the tasks queue and on the Ajax. And another visualization of event loop is the call stack, task queue, and the task sources. And from there, I would like to stop the presentation and actually show you a very nice thing that I discovered from the previous lecture that I would like to show to you. So now I'm demonstrating my browser and I have already shared in the chat this useful website. It's called Let and Flip Loop. And Let and Flip Loop, it allows you to visualize what is happening on the call stack, what is being run by the web API, what is being passed to the callback queue. So here we have some code. We have this is the jQuery syntax that we have been studying some time before, the $sign. So when we are clicking the button, then we will run the set timeout. You click the button and this code will be run after 2000 milliseconds. Then we have a piece of synchronous code, console.log hi. Then we have a set timeout function, click the button, and another synchronous piece of code, welcome to loop. I will give you a moment to analyze this code and predict like in which order it will be run, and then we will hit the visualization run. Okay. So now, if we click on Save and Run, we can see that this code is being highlighted and shown to us, like in which order it is being run. And it is extremely useful for us. And we see that that on button click is still on the AP because it has a delay. And then finally it is being run. So I have shared this website in the chat, and I'm encouraging you to use it because obviously you can add the code you like. Modify it and then run it again to see how it is being done. Like what is being logged out first, what is being logged out second, what is happening here. And I suppose it will be very helpful to you in understanding such a complex theme as event loop. And with that, let's go back to the presentation. One moment, I'll reshare my screen. Okay, now I'm resharing my presentation and let's go to our today's topic, the new stuff, the asynchronous JavaScript, the Ajax. So, what is Ajax? Ajax is a technique for creating fast and dynamic web pages. As we have discussed in our previous lectures, in the old way, the MPA application, multi-page application, on each and every subsequent server call, you are receiving the full HTML page back. So your full page is reloading. And obviously, this is not very good when you have a highly responsive application such as Instagram or Facebook. And Ajax allows us to run what is called SPAs, single page application, when we are only receiving HTML on the first server call, and then we are receiving our data separately. We are receiving it in another format. So Ajax allows web pages to be updated asynchronously by exchanging small amounts of data with the server behind the scenes. So for the end user, this is unnoticeable. You are just navigating the website, and until you open the network tab in your developer tools, you will not even notice that you are sending such and such request and receiving data. Everything is happening behind the scenes and giving you a smooth end user experience. So, what are good examples of applications using Ajax? For example, Google Maps. Google Maps hold quite a lot of data in it. And if, for example, at the first render after you navigate to Google Pages, it will attempt to load all the data about all countries, about all cities, about all streets and parks present in the world, it will be quite a long render. And obviously, it will not be a good user experience. So each time you are changing the zoom level on your maps or you are dragging your cursor to another part of the map, Google Maps are sending asynchronous requests to get more and more data. And I suppose this is especially noticeable when you have a bad internet connection. I suppose you have experienced it many times that you are navigating the Google Maps and you can see that at first they're like just green and blue screens, blue rectangles, and then you slowly see the streets appearing, and then you see the houses appearing, and so on and so forth. This is the asynchronous data slowly being loaded to your main screen in case of the slow internet connection. Apart from Google Maps, good examples will also be Gmail, YouTube, and Facebook. For example, on YouTube, the video is not being loaded all at once. You can actually see that you have like a dark gray bar. It's the whole length of the video. And then you have a light gray bar, it's a few shades lighter, which is showing how much of the video has already been loaded on your client. And if you have a slow internet connection, then the video will stop from time to time and there will be a loading circle appearing and you shall wait for several seconds until next part of the video loads. And YouTube only allows it as an option to download the videos if you have, like, I suppose the YouTube Premium, it's called, to load them locally on your machine. So I'm highlighting that Ajax is not a good experience with slow internet. And this technology, it was being developed as internet was getting better and better and better. Like by now, most of us have the really wide bandwidth internet connection in our homes, like 100 bits, 200 bits, and even on our mobile phones, we are mostly using like freely accessible Wi-Fi's in the city, or on our mobile plans, we still have the internet connection with very, very high speed. So it allows the applications to feed us data in small chunks asynchronously. So Ajax is meaning asynchronous JavaScript and XML. So what is XML? Let's see how Ajax is working, and then we look at XML as a standard of how we can pass this data. So how these asynchronous requests are being sent. First, in our browser, we have to do an action of some sorts. For example, we are clicking a button, and then using the XML syntax, which we will study today, we create a request object. Like we are collecting all the info that we need to send to the server. For example, if I'm on Google Maps, I suppose I will need to send my current coordinates, my current zoom level, and so on and so forth. Like, what information do I need to load? And then, after we have created this request object, we are sending the HTTP request. HTTP request means that it's being sent by the HTTP protocol, not HTTPS. It's not secure. Secure connection is usually more slow, but for Google Maps, I suppose we are safe to not be using the secure connection. Then, via the magic of internet, we are sending our request to the server, and the server is processing the HTTP request. So based on the info we provided, either we ourselves, if we are Node.js developers and we are writing JavaScript on the server, or our back-end colleagues who are writing in Java or in Python, they are writing the logic how to handle our requests. Usually on the server, it means communicating with some databases. So in the case of Google Maps, our example, we are sending the coordinates, we are sending the zoom level, and then we are getting information from our databases, like what buildings are there, what parks are there, what information shall we display to our user. Then we are updating this information, we are changing its format. I suppose you have noticed that Google Maps, they are not actually composed from images. They are what is called the vector graphics. So they are made from lines, which allows you to zoom in and zoom out more easily, and it allows Google Maps to recalculate it more easily. So based on the information from our databases, we are setting the coordinates for our vector graphics, and then we are sending this data back to the browser. Then again, via the magic of internet, of our World Wide Web, this information gets back from the server to the client, and then we are processing the return data using the JavaScript, using the logic that JavaScript Google developers have written on how to parse, how to read this data they have received from the server, and based from it, how to update the current map that the user is seeing in Google Maps with this new information. And that's when you are seeing these new streets appearing, these new houses appearing, and so on and so forth. And our page content is being updated asynchronously. So you don't have to actually reload your browser page in order to see the updated Google Maps. They are just updating as you are navigating the page. And if we look not at Google Maps, because it's quite a specific example with all its vector graphics and whatnot, if we look, for example, at Gmail, I suppose it will be even simpler. So, for example, you are writing an email, and after you have written an email, you are hitting the send button, and then we are creating a request object with like the sender, with the receiver fields, with the contents of your email. Maybe you have also attached some files to your email, some images or videos. This is all getting bundled together. Then we are sending it to the server. Your request is being processed, email is being sent, and then finally we are updating using the JavaScript, the document object model, the DOM, that you are seeing in your browser, and you will see new nodes appearing. From the end user point of view, it will be like some notification appearing in the browser saying your email has been successfully sent. Or in the case of an error, for example, your internet connection was abruptly, you disconnected from the internet. For example, you entered a tunnel while you were driving a car in the passenger seat. Please do not drive and send emails. And while you entered the tunnel, your internet connection was severed and you received, sorry, there was an error. We were not able to send your email. But still, your document object model was updated. So now let's talk about the XML. What is XML part in the HTTP request object? So XML is a software and hardware independent tool for storing and transporting data. What I suppose is the main thing here is that XML, it does not do anything by itself. As we have discussed on the previous slide, you have to actually send HTTP request. You have to create it, and creating and sending and receiving these requests, it is all being done separately by using JavaScript, by using logic. XML is just the syntax with which you are writing these requests. XML is just information wrapped in tags. So we must write pieces of separate software to send, receive, store, or display this data. Actually, I suppose it will be useful to think of XML as an HTML brother. These are both not program languages, but they are syntaxes. Like if you just write HTML, it will not do anything by itself, like you have to actually run it in the browser to see this page. By itself, HTML is just static. XML is quite similar, albeit XML and HTML were designed with different goals in mind. So XML was designed to carry data with focus on what this data is, and HTML was designed to display data with focus on how data looks. So XML is also using tags like HTML, and we will see this syntax down the line. And I suppose the main Achilles heel of the XML is that it's not very easy to use, and its usage can be quite complicated. So at first, XML kind of created a revolution in how we are developing websites, because thanks to XML, we were able to send these asynchronous requests and update the web pages with new data without reloading them. So it is what technically made SPA, single page applications, possible. But XML, due to its kind of chaotic nature, it actually set us back in web development for several years. So it came to us as a savior, and then it became a major drawback. So today we will study what new syntax was based on the XML, or what we are using now. Spoilers, it's promises, it's fetches, it's more modern syntax. And throwing us back to our previous lecture when we were studying the inheritance, and we were studying the four major pillars like abstraction, encapsulation, and so on and so forth. So XML was in the beginning, but then we developed a new syntax, a new interface to manipulate XML under the hood, but using much more convenient tools, making the developer experience much more cleaner and allowing us to send and receive data much more easily. And this is called a new abstraction layer because under the hood it's still XML, but from end user perspective, we are writing it differently. Like, for example, we are writing a promise. And then above promises, even more new syntax, new abstraction layers with new interface to manipulate promises were created. So I'm just adding this to highlight that abstraction, encapsulation, inheritance, they can be applied not only in the object-oriented programming, but with many other things, especially abstraction layers. Because if we are talking about this abstraction, it just means that we are making our experience as a developer more plausible. So if we don't use any abstraction at all, for example, theoretically, we can code everything using just ones and zeros, the machine language, because under the hood, this is what our code gets transpiled to through several layers of other interfaces. But I suppose coding in zeros and ones is not feasible. For a human, it will be extremely ineffective. We do not think in such a way in zeros and ones. And that's why we have begun to create more and more programming languages and programming languages based on other programming languages such as JavaScript, because, for example, it's not working with memory. It's not working with our hardware by itself. So it is using other programming languages to do it for it. So let's quickly return to our long history of asynchronous requests. Let's see. We will start from 1969. It was quite a long time ago. So here is where generalized markup language was created, and it was slowly transferred then to HTML, because HTML is also markup language, but it's hypertext markup language, so more specialized. Then transmission protocols were created. Maybe you're already familiar with such terms as TCP protocols, IP protocols. As front-end developers, we do not need to get into details on how this works, but this information is still quite useful to us. So, for example, if you were a system engineer, you would be very familiar with TCP IP protocols because they also handle how we are transferring data, but on a more granular, more closer to hardware level. Because when I'm just telling you that we are using Ajax, it's like a higher order standard. If we look deeper, if we look inside it, we will see that under it we have other protocol layers which are closer to hardware and actually enable Ajax to work. So if we go back to our timeline in 1980s, we have developed the standard GML, the standard generalized markup language. And in 1990, we have finally developed the HTML, something we are already more familiar with. And from there, things get more interesting. Because first, we have created static languages, and our pages were not responsive. But then, in 1995, JavaScript, the language we are studying today, has been invented by Brenton Eich. Then, in 1996, just 1 year past JavaScript, the XML is being developed. This format for allowing us to exchange data between the client and the server. So, what is going wrong there? If we look at the citation I have put in the top right corner of this slide, So XML is by far the silliest path of hothouse XML for its own sake to have walked out of W3C. W3C is a community responsible for developing the web. I suppose you have already read lots and lots of on its articles, especially when you are studying HTML. So it is bad engineering from beginning to end, and as such constitutes a prime example of how text XML as a means to deliver XML applications could become an unworkable mess through dynamic advocacy of bad designs. So let's see how this mess came to be. In 1995, we developed JavaScript. In 1996, we developed the XML, and then we have lots and lots of dots. We remember that there were lots and lots of browsers present on the market. And even though JavaScript, it's like one programming language and it has its own statement, it's called ECMAScript. Browsers, on the other hand, they were being developed by commercial companies. Like, for example, Internet Explorer, it's being developed by Microsoft. Chrome is developed by Google. Safari is being developed by Apple, even though like Apple was not developing it in 1995. Also, we have like Firefox, we have Opera, we have many more regional browsers, and so on and so forth. And all these browsers, they are working on their own. So they do not adhere to a strict standard. And so the implementations can be quite different from each other. And this led us to trouble. So what is happening? This a bit hard to pronounce thing that became the very example of the bad design, the XHTML. It's a new standard which was developed independently to be used. This is an era of web development which was marked as Microsoft Corporation trying to take more and more web under its wing, or in other words, just trying to conquer the World Wide Web and how things are being developed in it. So several standards were being developed simultaneously, and several commercial companies were pushing for the standards to become the one and the only. So extensible hypertext markup language, or this HTML, it was begun to be widely used, and it was being developed not by an independent committee of developers, not being developed for everyone, but it was developed by several companies. And so it actually stagnated and stopped the development of HTML in itself. And the consequences is that what is called the dark age of web development. And if you look at the HTML and when HTML4 was being released and HTML5, it's a very big year gap. So as we all know, by today, the Internet Explorer is not the main browser on the web, like the first place belongs to Google Chrome. And even Internet Explorer Edge, the new version, it was not able to take back the lead from Google. And even though Google Chrome is the leading browser, it is no longer dictating how World Wide Web is being developed. We have independent committees who are responsible for developing new ECMAScript protocols on which JavaScript is being developed, because actually even JavaScript had several protocols developed simultaneously during the dark age of web development. And so there were like several JavaScripts at the same time. Well, all in all, it was a nightmare. Thankfully, I'm too young to have experienced it myself firsthand, but my older colleagues have been telling me that, yeah, it was quite rough to develop during that time. So JavaScript and HTML and XML, all of these formats, they were being pulled in several directions simultaneously at the same time. But thankfully, this dark age is behind us, and right now we have clear standards being developed by independent committees. So let's finally, after this dark history lesson, dig into how everything works. So what is XML? XML is also using tags, the same as HTML. So it is not forgiving. So for example, if we forget the closing slash here, like we remember that there is an opening tag and the closing tag. So if we forget a slash, then we will immediately get the XML parsing error. And obviously, this makes creating XML requests very difficult, especially when you are not writing them by hand, but you are constructing them using JavaScript. Like you are getting some information and then you are wrapping it in these XML tags, preparing this information to be sent to the server. And each and every mistake will just mean that everything is collapsed, like your request will not be sent. So XML is not forgiving at all. In the top right corner of the screen, I have added the postal law. Postal law means that implementation should be conservative in its sending behavior and liberal in its receiving behavior. So this is a quote from the law made by amazing John Postel. Let me just paste his short biography in the chat. I will be very happy if you read it up, because this amazing man is the one responsible for the TCP standard, IP standard, and his recommendations still define how we are developing things till this day. So what he has created is the postal law. It's a guideline for creators of software protocols. And software protocols such as TCP, IP, the REST protocol. The REST protocol is how we are communicating between client and the server specifically. It's the protocol based on which Ajax is working. So the laws developed by John Postel, they tell us that you shall be liberal in what you accept and conservative in what you send. So as you can see on my slide, XML is not actually liberal in what you accept. Any mistake means failure. So this made XML quite unfriendly to use by developers. And despite that, error handling and correction is part of all data transmission and communication standards, XML is not doing it. Like if you make an error, oh, that's the end of the line. It's not working anymore. So it violates the robustness principle. For example, HTML5, the newer standard of HTML, was built with error handling in mind, as it specifies the methods how a page shall be processed despite its problems. So even if there are some problems in your HTML, instead of just receiving a big error that, hey, nothing is working at all, some page will render, like it will try to encapsulate your errors. So if you try to write some markdown and, for example, you will not put an closing tag in HTML, you can try it by yourselves, the page will not crash. It will at least partially display itself. So HTML5 will try to think what you could have meant when you made this error and still try to display the information. And this is the main purpose of HTML, displaying the information. XML is for sending and receiving, transferring the information. So XML was not robust at all, and it was violating the Postal's law. It was not robust. But if we look at other protocols, the TCP IP stack, as it's called, we will see that what we are doing, it is based on several layers. So what we will be working with as front-end developers is mostly the application layer. For for example, the message, the HTTP request based on REST protocol. So these are GET requests, POST requests, PUT requests. This is how you communicate with the server. And let me also post in the chat the HTTP requests. So here's a good page from the IBM that you can also read up after the lecture to know about HTTP requests in more detail. So we are sending our requests using the Ajax technology, and it will be received on the server. And as front-end developers, we do not need to get into deeper layers. Like we are just looking at this, and that's enough for us to do our job. So we are just looking at the application layer. We are sending data via HTTP request, and we are receiving it back from the server from HTTP request. We usually receive it in JSON format. So this is a special format for transferring data developed for JavaScript. And then we are displaying this data, manipulating it. Then we are again sending some data. But as I told you before, this is not where the story ends. And beneath this application layer, we also have transport layer, TCP segment, internet layer, IP, and finally the network layer, the closest to actual hardware, which is handling our requests layer. So thanks to this layers application, you can kind of think of it as an onion with lots and lots and lots of layers. This internet communication, it is handled on several layers at the same time. So when you are sending or receiving some data, additional information will be packed around the data as it goes through these layers. So when we are working with application layers, we do not need to worry about TCP headers, IP headers, internet headers, frame check sequences, and so on and so forth. As front-end developers, we just have to pack our data, snag HTTP header on it, and send it to the server. And then, closer to the hardware, all these additional layers will be added. And that's awesome, because we can just delegate this to system engineers. And this also makes the internet more robust than XML itself, because we have lots of layers and fallbacks. So, XML HTTP requests, it can actually work not only with the XML, but with any type of data. And that's awesome because later in this lecture, we will see how we can make our life much more simple and not actually write these XML tags nowadays. We can send information in other formats, such as JSON, for example. So the internet evolved and we were able to send and receive data in other formats. Let's finally look at some code examples. Here we have a function called request callback, and it's printing to console log this, which we have studied at our previous lecture with inheritance. We remember that this is not defined when the code is being written. It's defined based on where our code is being called. So if we call our request callback in the global scope, then this will equal to window. If we run it in the object, then it will equal to object, and so on and so forth. And then we are, as a second line, printing out to the console this dot response text. What we are doing? First, we are creating an instance of XML HTTP request. And XML HTTP request is a special type of object in JavaScript. And thanks to JavaScript inheritance, this XML HTTP request object has inherited some methods and properties. So thanks to this, we have, for example, access to request.getInfo. onload method. We did not define it by ourselves, but thanks to request being created using the new keyword from the XML HTTP request function factory, as we have studied in inheritance, our request has access to all these methods and also to the onload method. So what we are telling the JavaScript here is we are adding actually an event listener. So on load, when the load event happens, and we remember from our lection on the bomb that all event listeners, they are starting with on click, on key down, on key up, on scroll, on load. So when load happens, we shall execute the request callback, the function which we have written above. Then we shall set up a request. XML HTTP request, it requires to go through several stages. First, we must open it. We are not sending it yet. We are just opening it. We are preparing it to be sent. So this is the first stage. So we are opening our request, and then we are passing two arguments. First, it's the HTTP method, the method we will use to send this request in the future. So now in the opening stage, we are describing the specification we shall be using, like writing the instruction. How we will send this information? We will be sending a GET HTTP request. GET request means that we are only requesting information from the server. So there is no body in our request. We are just getting, as the name suggests, requesting information from the server. So the method is GET, and second argument in the open method is the API, the URL in other terms, which we will be calling. So we have to go to this address on World Wide Web and execute a GET HTTP method on it. Okay, we have set up our request in the open stage, and then we are hitting the send button. And that's all that send does. It's just sending the request based on the specification we have written out in the open stage. Okay, our request is being sent, and then after our request is loaded, so it's asynchronous request, it's being put in the event queue, and then after we have received our information from the server and the callback is empty, then we are actually like executing this request callback, and we see the results in the console. So we see that this equals to XML HTTP request. And we can see that it's a special type of object, and we have lots and lots of methods and properties on it. So we have on ready state change, ready state, timeouts with credentials, upload, and so on and so forth. If you run this code in the console by yourselves, you can see and inspect lots and lots of properties and methods that XML HTTP request has on it. But if we go deeper in this object, as we see, we have the second console log present, this .response text. So this means please display to us not the whole XML HTTP request, but only this part, the response text. And here we can see that we have received some information from our API spacexdata.com. We have received some object. Inside of it, we have headquarters, and it itself contains as value another object with address, Rocket Road, city, state. But you can see that it's actually not an object in what we are used to. If you remember in JavaScript, when we are writing an object, so let me open our chat. So for example, const object, which consists of keys and of values. And we remember that keys, they are not actually wrapped in parentheses. So this const object with one field with name Yana, it's correct syntax in JavaScript. But here in the response text, we can see that the name itself is being wrapped in parentheses. This syntax is not only object, it's the syntax which is called JSON, and it's a special syntax made for transferring objects. JavaScript objects between client and server. So JSON is called JavaScript object notation. So it's data interchange standard. So let me link it in chat. And it will look like this. So I will have to wrap everything in parentheses when I'm using JSON, but I also have to convert JavaScript object to JSON, to JavaScript object notation, and then I have to convert it back from JSON back to JavaScript object. So you can try working with this, for example, here in this JSON format website. Here you can take JavaScript object, convert it to JSON, and then convert it back. When we are actually running our code, there are methods we can use in JavaScript to actually do it by ourselves. So for example, we can use the JSON stringify method to actually convert our JavaScript object to JSON. And if we are not using any syntax abstractions above our JSON and XML HTTP requests, then we will have to do it manually. So for example, here's the method JSON stringify. I have sent it to the chat. So with this, we are converting our JavaScript to JSON. And what shall we do to actually do a backwards operation to see JSON and then convert it back to JavaScript? It's being done with another method. It's called JSON parse. I have linked it in the chat as well. And that's how we can communicate. We can convert JSON to JS backwards and forwards, because JavaScript will not understand JSON. It's a special format specifically for the data transfer. So let's see XML, HTTP. Yes, of course.
I have a question. In the previous, like the send methods, whether it sends a request.
Our send method does everything we have specified in the open stage, the previous line. So here we can see request.open. First, we are passing get. It's an HTTP method get. And second argument is an API. So it's a URL we have to hit with HTTP get method. And after we have outlined this specification, then we are just hitting send button. We cannot pass any specification here. It is just doing everything based on the information we have specified in the open stage.
So we will send to API space.
Yes, to API space 6 data v4 company something. Yes.
Yeah. Because URL is also a server.
Yes, so there are lots and lots of open APIs in the internet, and I suppose this is a good time to again close my presentation and open an amazing app called Postman. So one moment, let me open Postman and demonstrate this to you. And I suppose this will be a very good way to get better at understanding these requests. And I will link an amazing course. It's totally free. It's like 1 hour on YouTube on how to use Postman and send requests. So Postman is a special software. It's just an application on my machine, which allows me to send requests. So here we have the simple book API, and we can see that this is the base URL of this API. So if I open it in my browser, and it didn't copy it. Well, thank you. Full books API. can just find it here and open it. And we can see that it's not actually a website in what we are accustomed to. I cannot interact with it. This is just an API. So API means application programming interface. So this website, it provides me with interface to interact with it, but not as a user, but via HTTP requests. So I can send data to it, I can receive data from it, and because this is a special learning API, it's freely available. You can use it yourselves. I will link the learning materials in chat. And here I have what is called the documentation. Because interface, it means that you have to follow the rules in order to send and receive data. So when we are using API, we are sending data. Can you please open me just the image so it's bigger? Thank you. So when we are using API, we are sending the request and then it is being API accepts it, and based on the contents of my request, it contacts other servers and databases, and then it gets me my response back. So in order to manipulate this interface, as we have studied in our previous lecture, with inheritance, we have studied objects, object-oriented programming, and that objects communicate using methods, using interfaces. So in order to get something out of this API, because right now this website to me is a black box. I don't know how to use it. Like, welcome to Simple Books API. How do I request a book? How do I send a book? How do I get some additional information? I do not know it. And that's why each and every API on the web shall have what is called documentation. It's just an instruction how to get this information. So, for example, if I want to get a list of books, then I need to send my request not to this home page, but to send it to books. So if I just input it to my browser, here, books, then I see that I have actually received in JSON format an array of objects, an array of books, and so on and so forth. So using my browser, I can simply set something like get request, because with get, I'm not sending any body in my request. For example, here it says me that I can get a single book, and here we can see books and then book ID, but we have a special symbol before it. And this means that in order to use this API correctly, I shall send not book ID, because if I do it like this, it will not work correctly. Oh, now book with such ID. What I should do instead is go to books and see the book ID here. For example, if I would like to get more information about the book with ID 3. So what I'm doing, instead of adding this book ID, I'm getting /1, or in my example, 3. And here I have received some additional information specifically for the book with ID 3. So documentation provides me instructions on how to communicate with this API. And this is what you will be doing frequently, very frequently in your day-to-day job, because you will be constantly communicating with your backend team, receiving data from the server, but you will also have to post data to the server to not only get some information, but also to deliver something to the server. And to demonstrate this, the browser will not be a very good companion for me. So let's try Postman. Postman does the same thing, but it provides me with a very good interface, which allows me to input any information I would want. For example, here's my base URL. It's already familiar to us, simple books glitch me. And let's see how already familiar to us list of books get request. We can see it's get, and here we can easily change it. We have lots and lots of HTTP request types: gets, posts, post, patches, delete, copy, and so on and so forth. So get allows us to get some information from the server, post to deliver something to the server, put and patch are meant to partially update the information. Delete kind of speaks for itself. For example, you want to delete some information from the server. And there are lots and lots of others, but these are the main ones. So here in Postman, we are just inputting the base URL. We can see it's simple books glitch me. And for a moment, let me delete this. And then I will send this request. I am sending it asynchronously, some time has passed, and we see the already familiar to us response. And the text which I have just deleted, let me return it back. Here, as we have started with URL, this part is called the query. And here, for example, I'm adding some additional information on what I want to get from this API. I'm telling you, please tell me not only all the books that you have, but only the books which have the type. Here is fiction, but I only want to have non-fiction books. For example, this one is non-fiction with ID 2. And to do so, if this API supports it, and this one does, we can read it in the documentation. I'm putting a question mark, then this is the query parameter, then equal sign, and then its value without the parentheses. And if I send this, we can see that I have only received the books which have type non-fiction. And then let's repeat this with single book. So here we have books ID. So here I have this syntax. And with Postman, I can say that, hey, we have the ID key, and I can get any value I want. I can set it in my collection. For example, here I have set book ID to 5. And if I send this, I will receive information about the book with the ID number 5. And if I go to the variables and change this, for example, to 4, then we can see that instead I will get the information about book number 4. Postman is very useful in our day-to-day job because it's very easy to get more familiar with API. For example, here, this is APIs from my actual working project that I use in my day-to-day job. It has lots and lots of APIs. So before I'm actually writing JavaScript logic on how to handle this data, first I'm testing it in Postman, like how this API is working, what is it accepting, how shall I process this request, how can I send it properly. And after I get familiar with it in Postman, then I can actually write JavaScript code to actually use this data in our application. Postman is very powerful. It's used not only to just send requests manually, you can also write tests for your requests. You can also run all collections. But now let's return to post. So post means this type of HTTP request means that we want to publish something on the server. We want to add some data there. And for that, we have what is called a body of our request. In GET request, we don't have any body. We are not sending anything to the server. In GET, you only have access to what is called query params, what you are adding to the URL itself. For example, here we are adding ID, or previously we were just adding static books. But with post, we are able to actually post the body of our HTTP request on the server to add some data there. So for example, here I want to register the API client. And so I'm sending my request to API client, and let me so first I can view my documentation. For example, here we have post API clients, and documentation is telling me that to submit or view an order, you need to first register your API client. So my system, this API, it tells me that I shall first authorize so that system knows it's me and I can have access to this information. So I will need to make a post request to this address, API clients, and usually in documentation, instead of repeating and repeating this simple books API glitch me or whatever base URL, you will just see that it's demonstrating just a slash. So you shall know that before this first slash is usually the base URL. And we're just reading the instructions. The request body needs to be in JSON format, which we are already familiar with, the JavaScript object notation data interchange format, and it shall include the following properties: client name and client email. The response body will contain the access token, which is valid for 7 days. Okay, so let's try this. We have remembered all the instructions. And here, thanks to the magic of Postman, I can actually use such things as random. So if I'm using random, it means that each and every time I will be sending this request, Postman will actually send something random. So it will just generate random full name and random email, and it will give me the access token. So I can just go to my collection and then input it here. And thanks to this access token, then I can make more requests. For example, I want to order a book. So how to order a book? Let's go to post orders. How do I submit an order? As we can see, it requires authentication. So first we authenticated, we received our token, and now we are sending this post request to the orders. So again, reading the instructions, we need to send something in JSON format, we need to have the book ID, and we need to have the customer name. Okay, let's do it. We go to Postman, order a book. Let's inspect our body. So book ID, in our case, it will be 4 as we have updated it in our collection. So book ID is 4. And again, leveraging the amazing Postman things, we can just insert the random full name here. So let's try sending this request. And we see that we have created an order. So we are using this API properly. For example, what will happen if I do something wrong? For example, let me just delete this. There is only book ID present. And I will also have to delete the comma because JSON is not kind to trailing commas. I'm sending the request, and we can see that actually this API is able to accept it even with only book ID. But what will happen if I, for example, remove all body? Then it will give me an error. It will give me a status code for 100 bad requests. This request cannot be fulfilled due to bad syntax. So if I did something wrong, if I did not communicate with API properly, it will give me 400. If I fix everything and send the request again, we can see that our order has been created. For creating something, there is a special code called 201. And if we go to internet and analyze HTTP codes, we can see that there is lots and lots and lots of them. And when we are developing, we shall usually just remember the ranges. So when we're just receiving some information about the request, like is it okay, was it wrong, some additional info, it's usually from 100 to 199. When we are receiving something in this range, it means the request was successful. As we can see in Postman, our request was successful, 201 created. And this is what you usually want to see. When we are redirecting, it's this range, but the most popular that you will be seeing most frequently are successful responses, client error responses, and server error responses. And differentiating between these two will be very helpful for you. So if you receive something and there is 400 or 499 or something in between, you see that the error is on my side. I did something wrong. I sent something incorrect to the server, and this API cannot handle this information correctly. So I shall fix something on my side. But if you are receiving 500 errors, it usually means that something is not wrong with your request, but the server itself is experiencing some issues. So if you are working with backend teams on your server, on your project, this is usually the time to go to your colleagues and ask them about the server. Is it feeling okay? Maybe something happened. I suppose the one of common errors that you have, for example, experienced it is gateway timeout 504. This is an error which is happening when the server took far too long to respond. So you are sending request, something is wrong with the server and it is not able to process your information in timely manner, and then you will get a 504. I suppose you have experienced this sometimes while surfing the net. Another very, very popular error, so famous it already became a meme, it's a 404 error, not found. So if you are trying to find some information which is not present on the server, but the request itself is correct, you will receive a 404. So, for example, if we go to glitch me books and I will try to input some thing, we will see that there is no book with such an ID. And if I run this in Postman, get a single book, and here I will just, instead of this ID, just put this manual number, we will see this exact error, 404 not found. The request I sent in itself is okay. I sent a GET request to correct URL and I provided a number which can potentially be an ID of this book. But there is no such book in this database. So it is just throwing me a 404 not found error and telling me that there is no such book in this database. Okay, so we have ordered our book. Let's just copy order ID for future use and add it to my collection. Then we can, for example, get all of our book orders. But in order to get my book order, I have to use authorization. Our API told us that we actually have to be authorized. And we can see that to get API status, we have no authorization, list of books, no authorization, get a single book, no authorization, registering client, none. And then to order a book, we indeed have authorization. We are authorizing with what is called a token. So we have generated an access token, as you remember when we have sent this post request for registering API client. And we are sending this to server as our unique identifier. So we are telling server, hey, it's me. You can identify me by this access token. And this is how we protect our information from outsiders. So, for example, if I open email from incognito, it will tell me, well, yeah, in Armenian, because I am in Yerevan, but sorry for Armenian, but it will tell me that, hey, could you please log into your Google account? Why? Because the system does not recognize me. And if I go to Gmail from where it's just telling me no. But if I sign in and provide all this information, then it will tell me that, hey, now I recognize you and you can use everything. And actually, it's a very good idea to use double authentication so nothing bad happens with your data and it will send something to your phone. So if I use all this, then I can access my Gmail and look at my inbox. And even if I copy everything correct, like /mail u0 inbox, it will still redirect me like, hey, I do not recognize you. You did not provide me with correct authentication. So no, you cannot view this data. So please authorize again. This is what authorization means. It provides protection for, but here I have already authorized, and so here it does have everything, and it will correctly display to be my inbox, which is a total mess. Sorry. So let's return to our Postman and get all of our book orders. And here we are authorizing with our access token. So let's send our request. And we see that we got a 200 OK, and here all the IDs which we have just generated randomly. So if again I, for example, go to my access token and I will input something random in there, making it invalid. When I go there, it will give me also a very popular error 401, unauthorized. So unauthorized and forbidden. Unauthorized usually means that something is wrong with your authentication. So now we have an incorrect access token. And it's not giving me the information I desire because I do not have the permission to view it. But if I get the correct access token, again, then everything is working and I can view all of my orders. So let's copy some ID of the order. And then we can see that we can place and we can see more information about our order ID. So let's go to parameters, go to input our order ID here and get our order. And we see that, hey, there is indeed such an order. It was created by this customer. This is our authorization token. There is this book available, and this is the timestamp when it was created. So we can also update an order. This is the patch method. It allows us to partially update our order. So we shall also be authorized using our access token. And in our body, for example, we can change our customer name. So here we can see that we don't have such information, and I can say that, hey, I want to have my customer name as, like, for example, Jana with some random surname. Let's see what will happen. Okay, I received 204. It means that everything went well, but I did not receive any content. So this request for this specific API means that, hey, I have patched my order, but I do not receive any additional info from the server. So let's try to get my order again. And now we see that I have added some additional information to my order. Sorry, my boyfriend is spamming me. So this is the customer name, the new field, and it is me with some random surname. Now I'm suddenly Jana Simonis. And if we update an order again using the random last name, let's send this again. We receive 204. So we have updated something. Now let's get this information again. And we can see that everything stayed the same, but I have updated my surname again, and now I'm Jana Polic. And finally, by using the order ID, I can delete an order altogether. And delete order, it usually does not even need the body. So let's just with this, but we see that we are sending a specific, not get, not post, but specific delete HTTP method to our simple books API / orders order ID. So let's input our amazing order ID here and delete this order. And again, it was successfully processed with no content. Let's try to get this order now. And we see that we have successfully deleted our order. No order with such ID is found because we have already deleted it. And if we try to delete it again, then again, we will receive an error that, hey, you're doing something wrong. We have already deleted this order, so we receive a 404 not found. So Postman is a very good tool to get better acquainted with how to send requests, how to receive data from them, how authentication works. So I will link in chat how you can use it with a very nice course, free course on YouTube. So now let me share my presentation for a final time because we only have 30 minutes left to go. But we don't have many slides left. This lecture was a bit more practical, I suppose. So let me return. So here is the slide that we have stopped on, the basic usage of our XML HTTP request. And here's our API, what we have already started in Postman. So the status codes, the OK, unauthorized, not found, internal server error, the errors we have just discussed while using Postman. And with XML HTTP request, we have several event handlers. So on load. So when you have loaded the information, something will happen. As we have displayed previously, we have logged this information in the console on load event handler. But if error happens, so for example, in our Gmail example, you were trying to send some data, you were trying to send an email, but you entered a tunnel, your internet connection got severed, and so you were not able to send this information to the server. Something went wrong. So on error, handler will help you demonstrate to the end user this notification that, hey, something went wrong. So you can handle lots of outcomes, positive and negative, for your request, which is awesome. Now, let's see about this. As we have studied, when calling a function as a function, this would reference the global object. So on the left, we have function callback with console log this. We have our function constructor. And if we do not pass call method, which we have started, the apply, the call, the bind methods to actually bind the context, we will see that after we call it, we will lose our context because we are calling this function in the global scope, and this is referring to window. But if we use the call method we have studied previously, and we remember that call method, it accepts the context, and here we can do a very smart thing. So if you look on the right, we have function construction, return, call function, and then inside of it, we have callback.call this. And we are in this, it's very hard to say this grammatically and this in what it means in JavaScript, but callback.call and we are passing this inside. It means that we are referencing the call function because we remember that there is a global scope, function scope, block scope, and so on and so forth. And this, if called inside the function, and here we are calling it inside the function, it will reference with this call function. So we are binding the context as we have studied in previous lecture. And here, if we call this on the instance call function, callback, and it will actually demonstrate to us the call function instead of window. So a quick throwback to what we have studied with context lost and how it can be bound again. So here's another example of public API. With Postman, I have demonstrated to you how to use simple books API. Here's another example, SpaceX API. You can also go there, download Postman, try its documentation, and see how you can send and receive responses. I suppose it will help you to be more familiar with how everything works. And in our amazing developer console, we can also navigate to our network panel. And in the network panel, we can inspect each and every request that we send and we get. Because when we are sending and getting requests from the application, we can still view all of this data which we need to debug our application, to see how everything works, and so on and so forth. So how this works, let me reshare my screen once again. So I will demonstrate my whole screen. So here is already familiar to us Simple Books API. So if I go to F12, I will open my developer tools. And here we have the console, which is already familiar to us. So console log dot. I will print hi to console and so on and so forth. Next, I can inspect my page in Elements, which is very useful when you are developing new pages. I can also run lots of codes in sources, like here I have several macro, which are useful to me, which I run frequently. But what we are interested in right now is the network tab. So let's send the request to books. And here we can see that we received the 304 status code, and by clicking on this request, I can get into more data, and I can see the request URL, request method, status code, response headers, request headers, and here you can see the method, the path, and anything and everything. And that's how you will be debugging your applications when you are inspecting your application which you're working on, how it's communicating with its API, how it's receiving errors or information. So if I try to get information on some book, then we can see that, hey, everything went well and we received information on this book. And if I try to input some ID which is wrong, we can see that it's very conveniently highlighted as red. So all errors are highlighted in red to make it easier for you to spot and notice. And we can see that we got an already familiar 404 error, which means that this book was not found. Okay, so let us return to our presentation one final time. Sorry for switching lots and lots of times back and forth, but I suppose this is a more practical lesson, and doing it by hand is hopefully making this topic more understandable than just demonstrating the slides. So let's return here. This is where we stopped. Here is our network tab, and in preview we can be seeing this GET request, the codes, and see that response is usually in the JSON format. So there are several tabs: headers, preview, response, initiator, timing. By switching from the first headers tab to preview, you can actually preview your JSON response, which you have received from the server. So here you can see everything that this request got you from the server, which is again very useful to debug it. So for example, you can see, hey, am I actually not receiving this data at all from the server? Or am I not passing it correctly in my JavaScript logic in application? So for example, you want to display this dragon's data in your app. You want to display some card or list of cards, and nothing is happening there. So by analyzing the network tab, by the preview, you can see if you are actually receiving the data. If you are not, the problem is on the API side and you need to debug this part of application. But if you are receiving everything correctly here, then I suppose something is wrong with the JavaScript logic on the client, and you shall see how you are passing this data, how you are passing it inside your application, and so on and so forth. And here we can see that we actually got lots and lots and lots of information. And if we want to get one particular dragon by its ID, we can actually call only one and receive information by ID. Also, we can be calling several requests. We can call consecutive requests. So first you can get all the data, and then you can actually get information only for this Dragon ID with this open API. So what can happen here is called callback hell. If you have lots and lots of requests, if you have a long chain of requests and you have to handle errors and success responses separately. So, for example, if you got 404, then you have to initiate some logic which will demonstrate to your user that, hey, something went wrong. We did not find this dragon by this ID you provided, or we did, and then you need to do something else. And so we have callback inside a callback, inside a callback, and inside a callback, and so on and so forth. And this is what's called the callback hell. And previously, it was very tiring for web developers to navigate inside of it, because as we have learned, with each XML HTTP request, we first have to open it, write everything, how we will be sending it, then we have to hit actually send, then we will receive it, then we have to write the branching logic for good outcomes and bad outcomes, and then send something else. So with ES6, we have been given access to an amazing fetch API, and this is what we are currently using. So it replaces this XML HTTP request with a cleaner API. It means that it's a wrapper around it. So when you are using fetch, you will still be receiving your data in JSON, you will still be posting get, put, post HTTP requests, but how you are using it is much simpler. So let's see at the top right part of my screen, we have fetch. Inside, we are putting the URL that we are calling, and if we are doing a get method, we're doing get by default. So I don't even have to indicate that it's a get. To send a HTTP GET request to such a URL, I'm just calling fetch with URL. And then we have a new keyword called then. Then means do something asynchronously if the request was successful, if we received something in this 200 till 299 ratio. So then we are receiving the response, and then instead of JSON stringify and JSON parse methods, we can just call response.json, special syntax provided to us by fetch, which will parse our response. Then, after we have parsed it, we receive the actual data. And then using an arrow function callback, we can actually log this data to the console. And here's what we are getting in the end. So nowadays, we are mostly not using the XML HTTP requests by themselves. Instead, we are using this new API wrapped around them, the fetch API, which allows us to do it much more cleanly. And fetch is using promises under the hood, these microtasks we have studied before. So everything is a promise. Fetch returns a promise, response JSON returns a promise, then returns a promise, and so on and so forth. So then we need to do something with this promise. That's why we see that when we receive the data, then we are resolving this promise using this callback function, and then we are printing this data to the console. So we are receiving all data in JSON, but thanks to JSON method, we can easily convert it from JavaScript object notation to just plain JavaScript object and use it as we wish. So let's talk about promises in more details. So promises, they will run their callbacks, which we pass into them asynchronously. Promise is in essence a special object which can carry information about its current status. When we have just created the promise, it is pending. It is not being run. Then we are actually sending the request, and finally we are either returning with success from our battle or with failure. And if we want to do something on success, we are running .then method. And if we want to catch the error we have just received, then we are calling the .catch method. And instead of XML HTTP request callback how, which can be seen above, like XHR on load do something, XHR2 on load do something, XHR3 on load do something, and so on and so forth. And it's getting awfully nested and hard to read and hard to extend. With fetch, we get very clean .then, 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 or .catch, or .then again. We can very easily chain these methods because, as we have seen in the previous slide, everything is a promise. So each and every method returns a promise. And so we can easily chain these methods. And it allows us to handle very complicated logic simply. So promises are also very useful for handling other asynchronous situations. So you can be using them not for just API calls. Here in this example, we can see that we have a promise, and inside of it, we can actually use the set timeout, for example. And you can usually combine promises and set timeouts and set intervals so they are not excluding each other in any way. You can easily combine them and achieve the asynchronous behavior you desire in your application. So the resolved data will be available in the callbacks, both in resolved and in rejected states. So promises can be very useful to simplify your asynchronous data handling. So when you are passing the data from one then to another then, the callback which you are passing inside the promise, it shall actually do something with your data. So if we look at the slide, we can see that if we return undefined in one of our callbacks, we can actually return new data when we are just returning place, city. And then we can pass this new data later down the line. So each callback has the opportunity to do something with the data we receive. It is not by default that we are passing the same data later and later down the line in our then catch chain. We can simply modify this data, delete this data, change this data, put it in other places of our application. So with promises, writing these long chains of sending requests to the server or managing asynchronous behavior, it has become much more simple. So as we have studied several slides before, then can return a new promise as well. So with then, we return in a whole new promise. We can write this like specifically here. So then can return a new promise which will either resolve or get rejected, and we will handle this information in such and such a way that we desire. So with that, our quite eventful lecture on asynchronous JavaScript has finally come to an end. I suppose the main takeaway from this lecture is to get more familiar with how asynchronous code is being run and to get more familiar with sending and receiving requests as well. So first, because I have added lots of things to the chat, let me once again send this practical tool to play with async code. Here it is, latent flip loop. I strongly recommend for you to try it because it's absolutely awesome, and you will be able to input any code in there and see how it's being executed asynchronously. It will be especially helpful when you are writing promises to see how they are being resolved, rejected, what is happening here. Now, let me link the Postman course I have been talking about. It's Postman beginner course. This course is not necessary to be completed. I'm just adding it for your convenience, so consider maybe running through this course after you have finished these lectures as a whole. I don't think that, let me maybe say what this YouTube link is for easier later usage. So Postman, as I have demonstrated during this lecture, it can be extremely useful when working with APIs, but I don't think that it's mandatory for you to learn it right now. But if you desire to do so, it will be very useful for you later down the line. So I strongly suggest to later, when you have the time, when you do not have like pending homework tasks for the current course, to spend an hour or two and go through this Postman beginners course at YouTube. And with this, I suppose, yes, of course.
Do we still have time?
We have maybe like 10 minutes till the end of the lecture. So if you have any questions, yes, I'm listening.
Yeah, about slide 24, about the callback how. Can you describe us how on low work? Like we have many on low now.
Yes, so we are sending a request. We are creating an xhr.1 request. Let me maybe go back in our slides and see how we are creating it. So yeah, for example, here we are creating let request and we are doing everything. Like we are creating new XML request, we are adding their own load handler, we are opening request, sending it, so on and so forth. So here it is saved as request. Now we return to slide number 24, and we can just imagine that I have created beforehand the XHR1 request. I have done all these steps. I have created XHR underscore 2 request, 3 request, and so on and so forth. So they are existing in this universe. And then I am using the XML HTTP request API to do something on load. So if I want to chain my request, like first I want, for example, to get my authorization token, then immediately I want to display this information, then I want to do something else. And this is a very common situation in real world application. So with XML HTTP request syntax, this is quite cumbersome because I have to write onload equals function. Inside of this function, I have to like maybe write some logic, and then if I want to continue this chain, I'm creating separately another request, a separate request with all the steps I have demonstrated before. Like I have to open it. I have to detail with which method I'm sending this request, to which URL, so on and so forth. And then I'm again writing some callback function, onload, I'm passing another request, and this is getting worse and worse. So I can also link to the chat this awesome website. It's called callbackhell.com.
So it means when we write many onload, so we need to send many requests to trigger it, right?
Yes. Yes, so we have to create each request separately, and then we have to write the same code again and again. Like after this request finishes, we are sending this request, and then we are sending this request. And separately in the code, we have to first write everything about XHR1 request, describe it using the open syntax, the same for the next request, the same for the third request, and so on. And with fetch, it's much more simplified because with fetch, you are just writing fetch, and then you can easily, without creating new requests, again and again and again, because fetch is returning promises each step of the way, like everything is a promise with our fetch API, then you can easily handle them. Like you can say that we have sent something, then do something, then do something. If there is an error, catch something, then do something. So it's very easy to write long chains with fetch. And that's why we're using this syntax nowadays. It's just simpler on us and cleaner.
Yeah, that's right.
Yeah, so part of this lecture was like a very long history lesson on how awfully we lived before and how awesomely we are living now, I suppose.
Yeah.
So yeah, Fetch is awesome. And I see a question in the chat. API is simply used for accessing data. Is there any alternatives? So API is used for getting and receiving data. So API is application programming interface. So it is a very generic thing. So application programming interface can be organized in lots and lots of ways. For example, when we are using HTTP request, what we have been doing during this lecture, we have been using REST API. This specific application programming interface, which is running based on rules. Like we have GET requests, PUT requests, POST requests. So application programming interface is just a term, like how we can run things. And then we have to write an implementation of this interface. And REST API, which uses HTTP with its methods, is just one of the ways to run it. But it is the dominant way. We are running everything on the web. So yeah, like 99.99% of the time, we will be using REST API and HTTP methods. Is Promise synchronous? No, Promise is asynchronous. If we go to the very beginning of the lecture, we can see that we have synchronous code, and then we have microtasks and tasks. Both microtasks, which are promises, and tasks such as set timeouts and our Ajax request, which we have studied today, they are all asynchronous because promise is still waiting for be resolved. So Promise, it allows us to use a very convenient syntax to handle asynchronous data, but still it will be waiting for the server response or it will be waiting for other synchronous actions. So Promise is always asynchronous code. Okay, Are there any other questions? Thank you too for asking questions. And let me just post an article on MDN which tells about promises in more detail. And if there are no more questions, then I would like to wish you an happy Friday and awesome weekend and happy studies. Happy to be teaching you. Have an awesome weekend.